In this video, we'll work a third example of separable equations. Now we're going to involve an IVP. So we'll have some initial conditions as seen on the screen. So first thing, looking at that, we always want to see, can I separate them? Can I put the y's over with dy? Can I keep x's on the other side? We can. If you divide by y minus y-1, that brings the y to the other side, leaving us with a 1 over x plus 3, and then multiplying that side by dx. Notice now I have dy with y's, dx with x. It was separable, so I'm going to use this method. I'm going to take the integral both sides. All right, these are u subs, just like last problem. U sub is y minus 1, which means du is dy. So we get to do a straight integral here. This ends up being ln of the absolute value of y minus 1. Because they're going to get 1 over u. 1 over u is ln of u, which leaves us with this ln. Okay, same thing here. We can do that exact same thing, but we can let u equal x plus 3. And du is going to be dx. All right, we get 1 over u, which is ln of u. And then we replace it with x plus 3. So we get ln of x plus 3. And then don't forget the dreaded plus c. All right, from here, this is where I don't solve for y. I take my integral. Once I get down to not having the dy dx's anymore, and I get down to almost my answer, like right now, I use my initial condition. So using y to the negative, y of negative 1 equals 0. So it's x is negative 1, y is 0. So we get ln of 1, plugging in 0 there. Then I get ln of plugging in negative 1, we get ln of 2 plus c. ln of 1 is 0, so that tells me that c is negative ln of 2. Now I know c, so I'm going to plug that in. ln of y minus 1 equals ln of x plus 3. And now I'm going to plug that c there. Now there's no c. That's an implicit solution. We should go to explicit because you can on this one. There's a log rule. I don't know if you guys remember. I hope so. Let me write in a different color up here because it'll stick out. Log of a minus log of b is equal to log of a over b. Same thing with ln. So in this case, I get ln of y minus 1 equals ln of, we get x plus 3 over 2. Now I take e to the both sides to e, and if I do that, e here, e there, the e's and ln's cancel out, and I get absolute value of y minus 1 equals the absolute value of x plus 3 over 2. Now I would really like an explicit if I can get to it, so I drop my absolute value on one side and put a plus or minus out front. And then we can do one more thing. I can add 1. So y is equal to 1 plus or minus the square root of x plus 3 over 2. That is my explicit solution. This is a particular explicit. No general. General would have been up here, right? We would have a family of solutions for c there because I could plug in whatever c I wanted to. But because of the initial condition, that tells me that I had to plug it in. That wasn't my general solution, by the way. There was a couple lines up. It's right here. Didn't go far out enough. That's my implicit general solution. But if I want the particular implicit, that's what that is. Or single solution, whatever that may be. So sometimes you'll have to go to implicit. It really just depends on the difficulty. On assessments, I will make it known what I want you to go to.